Welcome to another video lecture. In this video lecture, we will see some more numerical problems based on Routh stability criteria. So, in this example 1, this is given to us. Find the value of k for which the system represented by the characteristic equation s to power 4 plus 2s cube plus 3s square plus 2s plus k equals to 0 is stable. So, we know the stability condition in Routh-Hurwitz criteria if all the elements of the first column of the Routh table are of same sign. If there is no sign change in the first column of the Routh table, then we will say the system is stable, otherwise system is unstable. So, let us apply this condition and then find out this value of k. So, we will first solution of this problem, we will first draw the Routh table for this characteristic equation. So, we will start with the highest power of this characteristic equation, which is s to power 4, then s cube, s square, s to power 1 and s to power 0. So, the first coefficient of this is the coefficient of or the first element of this row s to power 4 is the coefficient of s to power 4, which is 1. Then we will take the alternate coefficient, which is 3, and then the next alternate coefficient is k. Now, the next s to power 3 row elements will be the coefficient of s to power 3, which is 2. The next alternate coefficient is again 2, and the next alternate coefficient is 0. So, this is how we determine the first two row elements of the Routh table. Now, the coefficient of s to power 2, we will do this calculation: 2 multiplied by 3 minus 2 multiplied by 1 divided by 2. So, let me write it here: 3 into 2 minus 2 into 1 divided by 2. So, this will comes out to be 2. So, the first element of this row will be 2. The next element will be 2 into k minus 0 into 1 divided by 2. Let me write it here: 2 multiplied by k minus 0 multiplied by 1 divided by 2. So, this will comes out to be k. So, this will be k and the remaining element will be 0. The next row, the s to power 1, the first element here will be 2 multiplied by 2 minus k multiplied by 2 divided by 2. So, this will be 2 multiplied by 2 minus 2 into k divided by 2. So, this will comes out to be 2 minus k. So, this will be 2 minus k here, and the remaining coefficients will come out to be 0. The s to power 4 coefficient, we know this is a constant term. So, this will be k. Now, this is given in the question that the system is stable. Now, the condition for the stable system is that the first column elements, there should not be any sign change in the first column of this Routh table. So, this is positive integer, this is also positive, this is also positive, this too. Now, this value 2 minus k, this should also be positive, since the system is stable and there should not be any sign change between these two rows, s to power 2 and s to power 1, and hence let me write it here: this 2 minus k value, this should be greater than 0, and we can say that the k should be less than 2. Similarly, this k also should be greater than 0. This k should also be greater than 0 because the system is stable, there should not be any sign change. So, finally, with these two conditions, we can say that this value of k should lie between 0 to 2. So, this is how we will determine the value of k by applying this rule of the stability in the Routh-Hurwitz criteria. Let us take one more example of this type of questions in Routh-Hurwitz criteria. Now, in this particular question, the system is given and we need to find the value of k for this system to be stable. Now, there is no direct value of the characteristic equation is given in this question, but we are given with GS and HS. Now, if you can remember the closed loop system, the general closed loop system, in a general closed loop system, this is GS and this is feedback gain HS, this is the output CS. So this is the general block diagram of a closed loop system. So if you can compare this given system with this a standard closed loop system, we can say that the value of GS is K divided by S square plus 2S plus 2 multiplied by S plus 2, and the value of HS feedback gain is unity, since there is no feedback given, so this is unity. And we also know that the characteristic equation is given by 1 plus GS HS is equals to 0. So hence we can write these values GS and HS in this. So K divided by, let me multiply these two and solve this. So this will comes out to be S to power 3 plus 4S square plus 6S plus 4 multiply by 1, HS is 1, is equals to 0. So finally the characteristic equation comes out to be 1 plus GSHS equals to 0. So there will be 1 plus GS. So this will be, let me take this 1S cube plus 4S square plus 6S plus 4 plus K, and the denominator term will go to 0. So this will be 0. So this is the characteristic equation for this system. For the given system, this is the characteristic equation. Now we need to find the value of K for this system to be stable. Now this particular problem is same as the previous question which we just solved. So let me solve this. So we have the characteristic equation given as S to power 3 plus 4S square plus 6S plus 4 plus K equals to 0. Now the system is stable, then we need to find the value of K. So again we will make the Routh table for this question. We will start with the highest power, S to power 3, S to power 2, S to power 1 and S to power 0. So the coefficient of this row will be 1, 6 and 0. The next row coefficient, S to power 2 coefficient will be 4, then 4 plus K and 0. Now this first element of the S to power 1 row will be 4 into 6 minus this 4 plus K into 1 divided by 4. Let me write it here 4 into 6 into 4 minus 4 plus K into 1 divided by 4. So this will comes out to be 20 minus K divided by 4. So this will be 20. Let me write 20 minus 4 divided by K, and the remaining element will be 0 since these column elements are 0. So this will be 0, 0, and this S to power 4 term, we know this will be the constant term. So this will be 4 plus K 0, 0. Now this is given that the system is stable, hence there should not be any sign change in the first column of this Routh table. Now these are the positive values, hence this value should also be positive. So 20 minus 4 divided by K should be positive, and we can say that K should be less than 20, and again this 4 plus K, this should also be greater than 0. You can say that K should be less than minus 4. So finally we can say that the K should lie from minus 4 to 20. So this is the value of K for which the given system will be stable. So I hope you understood these two problems. Thank you.